Alright, we're at the end of the road here for CCNA 1, chapter 11, last chapter in the set. So this is going to be a little bit of review, some things we've seen before, putting it all together to build a small network. I'm going to try to go through this relatively quickly. We'll see how fast it goes. But again, a lot of the concepts are from prior chapters. So here we go, developing our devices in a small network is what we start off with. We talk about, sorry, I skipped a little bit. Network security, basic network performance. There's about 3 brand new commands in this chapter, SSH, and a couple other security commands that we're going to talk about later on, but that's really all that's brand new. Everything else we've kind of touched on. We've talked about small network topologies, how they're set up. They aren't too different from larger networks. Larger networks are just going to be, well, on a larger scale, more routers, more switches, maybe more modularity to their systems, easily added to and expanded upon if need be. So not too much different in small networks with topologies, usually connected through a single WAN. You see here a little bit less redundancy. Redundancy is not going to be as huge a factor in smaller networks, because if something goes down, easier to replace. Maybe you have a backup sitting around, but redundancy not such a big issue in smaller networks. Anything else here? A router and a couple switches, all you're really working with there. And the management of a small network is usually done by an employee of a third-party company. You don't have a dedicated IT team for a small business, typically. Selection of device selection for a small network, really about the same as a large network. You want security, quality of service. Do you need voice over IP support? Do you have a need for a layer 3 switch? Network address translation and DHCP. Of course, whatever type of network you're going to design, cost is going to be a factor. Speed, ports available, how manageable is it, how expandable is it. So things we've touched on a bit as we've gone through the course. We've talked about IP addressing and the importance of that for troubleshooting, for maintaining the network. So we've got some of those concepts revisited here. Address space is a crucial component of network design. All devices need an IP address, and your addressing scheme should be planned out carefully, documented, and maintained. Address space documentation can be useful troubleshooting, and address documentation is also very important when controlling resource access. So we've talked about this really in the last, well, chapters 7, 8, 6, 7, and 8 really, as we were talking about IP addressing in the network layer. So again, that's kind of material we've gone over, revisited. Redundancy, we just touched on actually a second ago, is important because a device failure can cripple your network. Redundancy is going to be a bit more important, like I said, for larger networks than for smaller, but still, it is a good idea for smaller networks as well. You don't want one device to go down and to have all business halted. If you can't communicate over the internet, that can cost you X amount of dollars. Just depends on how much business you are doing. So redundancy is going to be a good idea no matter what size network you are on, but more important, or sorry, what size company you have, but more important for a larger company with a larger network. You won't sometimes see as much redundancy in smaller network setups. You might just have one switch, one router, and devices connected to those items if it's a very small company. Or you could have a setup similar to this. Depends on the network you're working with. Traffic priority, traffic management is also something you want to design around. We don't get into quality of service or anything like that in these materials, but as something you will be setting up eventually. It's beyond the CCNA 1 scope, but having some traffic priority set up is a good idea in general. as you can see, that your traffic will be sent to the backbone of your network, possibly an ISP, in order of priority. So that's going to be important to set up as well. We have small network applications and protocols. We just spoke on applications a bunch in the last chapter, the application layer. So again, we've touched on this before. Network applications used to communicate over the network, email clients, browsers, type of application, programs that interface with the network and prepare the data for transfer our application layer services. We've talked about HTTP, SMTP, things of that nature. Define standards and data formats to be used. Again, we've discussed this in earlier chapters. All right, again, some protocols we've talked about, DNS, Telnet, what their role is. This is more chapter 10 stuff, processes. On either end of the communication session, they define processes on either end of the communication session, how messages are sent and expected to response, and the expected response, types of messages, syntax of the message, yada, 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 on down the list. So all that's there for you. I'm not going to spend time here. Real-time applications, infrastructure, voice over IP, video conferencing. All right. Scaling to larger networks. So to scale, we've got network documentation that is going to be important. How exactly your network is set up, how are you going to build upon it, your device inventory, your budget for expanding the network, and your traffic analysis. What traffic, what applications are producing the most traffic, what are your peak traffic hours, things of that nature are things you're going to want to have documented. Protocol analysis and analyzers allow you to capture what type of traffic is going across your network, how much traffic there is. So a network administrator must understand the protocols in use in the network. Protocol analyzers are tools designed to help in that task. For more accurate protocol analysis, it's important to capture traffic during high utilization times or peak traffic times. The results of the analysis allow for more efficient ways to manage traffic. Some traffic is going to be heavier or lighter on different segments of the network, so you want to monitor different segments separately and see who's doing what departments are doing what, however your network is broken down. So it's going to be important to compare those numbers. Based on these numbers and these analysis, then you can make changes to the network if need be, if you see a way to optimize speed and connection. You could also take a look at what applications are in use at an employee workstation. I guess you could pull up a task manager if, for instance, your employee is using Windows XP for some reason. Well, anyone would work, of course, but this seems to be a Windows XP window. You can pull up the task manager whether you're on Windows 7, 8, 10, whatever. So that'll allow you to see what processes are being used. You could use something like the snipping tool or a print screen to capture this and see what exactly is going on an employee's computer. Again, more information that could be gathered there for documentation purposes. And we move on to network security. This is where we'll have a couple new protocols and processes brought up. So security threats and vulnerabilities, we already had a chapter on this: information theft, data loss, manipulation, disruption of service, identity theft. We've talked about different threats, I believe, in chapter either 1 or 2. I can't remember, so I'm going to skip past that. Physical threats, you could have hardware, environmental, electrical, maintenance. You might want to have your devices locked up in a cage so no one can access them. You want to have them away from other electrical equipment that might harm them, so on and so forth. Again, this is a repeat of chapters 1 and 2, so I'm not going to spend much time there. Types of vulnerabilities, technical vulnerabilities, configuration, security policy, lack of security policy, updating things, keeping things updated. If you don't have a great security policy, then that is going to make you more vulnerable. So again, revisited. I'm going to skip past this. This is from chapters 1 and 2. Network attacks. We talked about viruses. We talked about worms and Trojan horses and what they are. Viruses are things that infect your device and expand throughout the system. Worms self-replicate over a network. Trojan horses, they will disguise themselves as a program but actually be a malicious piece of code intended to harm your device. Again, we've discussed this in prior chapters. Here we have reconnaissance attacks, and reconnaissance is basically gathering information, the discovery and mapping of systems, services, or vulnerabilities. Often not considered attack on its own because you are gathering information, but you have bad intentions with that information that you are gathering. You got access attacks, the unauthorized manipulation of data, system access, or user privileges. Okay. You've got some that can be classified as password attacks, trust exploitation, port redirection, man in the middle. We talked about man in the middle. You can see an example of trust exploitation over here. We're going to go over some ways to prevent a password attack, trying to guess somebody's password in just a moment. And some examples of port redirection and man in the middle. Okay, talked about man in the middle before. Denial of service, the disabling or corruption of networks, systems, or services. Basically, you are hammering a server with a bunch of requests for service, preventing someone who has a legitimate request from getting that request fulfilled. So we talked about DOS and DDoS. Okay. DDoS is when you have a bunch of bots or zombies also hammering on the victim. So we talked about that. Sin flood, sending a bunch of sin messages. Ping of death, pinging over and over again. Okay. Smurf attack, you can see down here, is an attempt to overwhelm a WAM link with ISCMP packets. And you've got Gargamel down here, and that's how you prevent a Smurf attack. It's a little known fact that Gargamel will prevent a Smurf attack. And for those of you kids who don't remember Gargamel, no, there's no such thing as Gargamel. Well, there is such thing, but it has nothing to do with Smurf attacks on a computer. It has to do with other types of Smurf attacks. Backup, upgrading, and patching your software. So network attack mitigation, how do we stop it? We've talked about these best policies before. Backup, upgrade, and update and patch. Just making sure everything's up to date. Typically, updates are going to protect you more from outside threats. So keep everything up to date, upgraded. We talked about this as a best practice before. AAA, authentication, authorization, and accounting. They provide access control on a network device. Who is permitted, what they can do. Okay, with passwords and whatnot. Who's allowed in. What can they do while they're there? What actions can they perform while accessing resources? Access control lists are not something we talk about in CCNA 1, but in CCNA 2 we have a lot of material on access control lists. So we will be controlling what protocols can be used, what the users on our network have access to, and what they can do with that access. So we'll be controlling that in CCNA 2. Here we have our firewall, which does control traffic and help prevent unauthorized access through things like packet filtering, which prevents or allows access based on IP or MAC addresses. Got application filtering, which prevents or allows access by specific application types based on port numbers. URL filtering, which prevents or allows access to websites based on specific URLs or keywords. Then stateful packet inspection, which basically checks that incoming packets are responses to legitimate requests made from within your network. That's stateful packet inspection. So those are some things that firewalls will do. Endpoint security, which is securing those devices at the end of your network, desktop PCs, laptop PCs, becoming more and more challenging as you have more and more employees with mobile devices. They need to be trained appropriately on the best security practices, and probably most of your problems are going to come from employees doing things they shouldn't be doing, unfortunately. I think we've discussed that as a layer 8 problem. That is the user problem that you have on your network. So that will be a hurdle that we have to deal with. You'll see some security policies in use with accessing your company's network, email. I know when I sign into my Huntington Beach Adult School email, they always have me enable a security protocol that allows them to wipe my phone, or that allows the wiping of my phone if need be through that email app. So while that sounds a little bit too much, but that's one security method they've decided to implement. So at least that's on my Android phone. I don't know how it works on iPhones. So I'll never have an Apple device. Never have, never will. Just a personal choice. Anyhow, moving on. We got device security. This is going to be our Cisco device security. On our Cisco devices, sorry if that was loud, on our Cisco devices, we have a process called AutoSecure, or a feature called AutoSecure, that will turn on certain security features that we could turn on our own, but it'll kind of just make a blanket sweep security feature change across your device. Do you really want to do that and not be sure what exactly it's turning on? If you know exactly what it's doing, then sure. But it may be a better practice to go through and secure those things yourself. You might even end up causing yourself problems by having a security feature turned on that you didn't even want turned on. So weigh your options. Do you want to use AutoSecure or not, or set things up yourself? Other than that, you should be changing your usernames, default usernames and passwords immediately. Restrict access to system resources to authorized individuals only. Turn off unnecessary services, and of course update any software and install any security patches prior to production operation. We've talked about passwords, best practices, so there's some of them here. Read them and done. So use a phrase, you can use a phrase however it is you want to do. You don't want to, use simple passwords and follow the guidelines on the screen. Now we get to some things that we haven't seen before. Okay, so you've got the ability, well, we've seen service password encryption. We know that encrypts our passwords. You also have a minimum password length that you can use. So you can see that command's pretty simple. Security password min length, and just type what you want the minimum character length to be for your password. That's it. So that's an option. You're not going to have employees using if you have employees setting up the device, short passwords that might be easily guessed. Okay. You've got the ability to block password attempts. So if somebody's trying to brute force out a password to get into your device, you can block them for a certain amount of time if they have a certain amount of failed attempts. So you've got the command block for. How long do you want them to be blocked for? This would be 120 seconds or 2 minutes. After how many attempts? 3. Within how much time are those attempts allowed? 60 seconds. So you're going to block them for 2 minutes if they have 3 failed attempts within 60 seconds. Okay. And exec timeout basically means if you wait a certain amount of time before entering a password, Actually, that's the previous command. Exec timeout is idle users. So if you have an exec timeout of 10, that's going to be, if you're idle for 10 minutes, it's going to go ahead and kick you back to the start screen. You'll have to log on to the device again and start working again. So exec timeout is just that. If you want a unlimited exec timeout, you can do a 0 and that will make it so there's no timeout at all. Otherwise, you're placing in some value that you want the exec timeout to be. Right there. So those are some new items, everything from minimum length down to exec timeout. Then we have SSH. So SSH, you need to use this. Well, you don't need to. Yes, you do need to, but you don't need to. If you want to be secure, you do need to. Use this instead of Telnet. Telnet is not secure. All of your passwords and everything you're typing in is being sent across your network in plain text. Okay, so if somebody is monitoring the network, sniffing your traffic, sniffing your packets, then, well, they're going to have all the passwords that you enter in for that device, potentially. So SSH will encrypt that traffic, and here's how you set it up. It's a little bit longer of a process than Telnet. So first thing you need to do is you need a domain name of some kind. It doesn't need to be something.com. In this case, they use span.com, but the command is IP domain -name, and then whatever you want that domain name to be. Okay, so you need to have that set up. You also have this crypto key generate RSA, general keys modulus 1024. So that key that you generate and the number that you see there, it can be anywhere between 360 and 2048 bits. Okay, a common one to choose is 1024, like they've chosen here. But just so you know, when we go through this in the lab, it's not going to accept this entire command. Now, your normal device would. This is a command you can put in. But instead of going crypto key generate, general keys, blah, 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 you stop at RSA. Okay? In the lab, in the packet tracer, you will go stop at RSA, press enter. It's going to ask you how many bits you want. You won't have to type in general key modulus 1024. So you just type in the number you want. You want 1024, 512, 2048. So that's what we'll do in the lab. On a normal device, you can use this whole command, or you can use the one we do in the lab. Either one will do. Okay. Let's see, moving on down. You do need a username set up. You do need a username. And you need, well, some type of password associated with that username. Okay. So you'll use this command, username, whatever you want the name to be, secret, whatever you want the password to be, because you're going to use that username and that password to establish your SSH. All right. So you want to make sure all that's set up before you go into the VTY line and activate SSH. Okay. If you were perhaps telnetted in and you did this, then it would probably go ahead and kick you out. So it will go ahead and kick you out. If you're doing a console, you'll be fine. But if you were telnetting in and setting this up and you didn't put in a username, you kind of just locked yourself out if you enable SSH. All right. So we got our username, password. You're going to your VTY lines. Instead of just typing login, you're going to say login local. That will allow you to use that username and password to get in. You've got transport input SSH. That enables your SSH on the VTY lines, and then you are done. Okay. When you're looking to access SSH from the command prompt, you can use this line down here. If you're using PuTTY, there is a section for SSH. It'll allow you to type in your username and your password and just go ahead. But if you're using the command line, then you're going to type in SSH-L or login-L space your username that you created space whatever the IP address is of that device you're trying to SSH into is. So that's what you'll see there. This is going to be an important part of the chapter. This is what we will have our lab on in chapter 11. Okay. Backing up and restoring configuration files. So we can either back up and restore from TFTP or from basically your flash drive or USB drive. Okay. As a matter of fact, this material was in the 5.1 version of this course, but is not in the 6.0, which is what we're in version. If you want to take a look at it, I mean, it's not like it's dated or anything. There's still valid commands for backing up and restoring your iOS, your configuration files, but they're not going to be in our tests. So if you want to take a look through them, go ahead, but it's not there for us in our materials. All right, so we're going to go right down to here, basic network performance. And again, we'll be revisiting some things we've already seen, like ping, traceroute, so on and so forth. So we've got the ping command. We've used that a little bit. So verifies layer 3 connectivity, and some of the symbols that are associated with it, the exclamation point, the period, the U, okay, and unreachable, so on and so forth. So you've seen those as we've used the ping command in class. Alright. A couple more examples of ping down here. Extended ping. That's going to be if you see here, you type ping without typing an IP address. You can press enter from privileged exec mode, and it's going to ask you a series of questions about the ping you'll have to respond to. So that's going to be an extended ping. Network baseline is something you can generate by using ping or other commands that will give you back a response time for specific connections. You'll take those response times and kind of compare them over different periods of the day and establish this baseline for which you consider to be normal network activity. Then you can use that baseline to see if there's any increased delay or anything like that, so you know if there's a problem going on in your network. So that network baseline can be established again by using ping and other commands and at various times to establish that baseline, and then from there, if you have a baseline for, let's say, a certain time and things are taking longer to respond, you might have latency issues or something to troubleshoot on your network. All right, traceroute is another command we've seen. Traceroute can show you where a problem is taking place along the path from your source to your destination address. For instance, this output down here, we've got a couple devices we're pinging from this guy here, it looks like. And as far as we got was to the 10.0.0.254 router here. So our default gateway is as far as we got. We weren't able to get to router B. So that's how we know how to start troubleshooting. We could start troubleshooting router A. Maybe there's a problem with its interface that's connected to router B. If we took a look at router A and see that everything's okay there, then we move on to router B and see what the problem is perhaps there. So that is what a traceroute would be good for. Got some various show commands, many of which we've already seen. Show running config, show interfaces, show ARP, so ARP table, show IP route, that was just like your trace route on an end device. Show protocol, show version. Alright, so we've seen these at one time or another. We've seen IPconfig all. I'm not sure if we've used IPconfig display DNS, which will show, yeah, we have shown all of our cache DNS entries, so we've used that one before as well. So again, more review. Okay, we got ARP-A and ARP-D, which we have also discussed. ARP-A shows you your ARP table, ARP-D is going to clear it. show CDP neighbors we have not discussed. Well, we did in, I think IPv6, but let's discuss it again. So show CDP neighbors, Cisco device protocol, I believe is what it stands for. Cisco Discovery Protocol, actually. And this is something that runs on all of your Cisco devices as they boot up by default. So what it allows those Cisco devices to do is to use layer 2 addresses, which are automatically configured so you don't have to do anything yourself, to see what other Cisco devices they're connected to. So they'll automatically discover other Cisco devices on the network. So that's Cisco Discovery Protocol Neighbors. All right. So they'll know all this information based on this protocol running. Okay, so you've got your device identifiers, which gives the host name of the device. You've got address list, which will include your MAC address, up to an IP address if that's configured. Again, an IP address does not need to be configured for CDP neighbors to work. The ports that are associated, or the ports that it's connected to or has active. The capabilities of the device, is it a switch, is it a router, what does it do, and the platform, what model number is it, basically. So those are all things you'll see in the CDP neighbors command. Okay, you can see a little bit more if you do a CDP neighbors detail. I think that's probably on the next slide. Yep, it reveals the IP addresses of all neighboring devices, regardless of whether you can ping that neighbor, because again, this information is shared at a layer 2 level. It's shared at a layer 2, so even if you can't communicate via layer 3, it'll show the layer 3 information. All right. It can be a security risk because they are sharing that information by default. If you want to disable it globally, you see the command there, no CDP run. Okay, just to disable is a sword, actually. To disable the CDP on an interface, you're going to use the no CDP enable command. We've seen show IP interface brief, so this is more review, and that's the last thing we have in this chapter. So it's the end of chapter 11. It's our final chapter. A lot of review in here, but a few concepts that are new and important, which we will discuss in class, and we'll start getting ready for the final after that. So that's it for chapter 11.